All right, I'm back to finish number 6. Let me go find it. Here it is. So I had to stop yesterday. But all right, so I did A and B. A is right next to the painting. B is in blue down here, and then we found out the predicted value of this painting in 2025, and we rounded to the nearest $1 million. And now let's look at C. Estimate the rate of change of the painting's value rounded. Okay, now this one sounds almost similar. It's almost same as B, but we are looking for what? The rate of change of painting's value rounded to the nearest $1 million in 2025. So same year, 2025, so our T is still 75, just like B. But we're not plugging in 75 into V of T, right? We're going to have to find the rate of change function, which is the derivative function. So let's go ahead and find V prime of T, and then let's plug in 75 there. So what was V prime of T? I'm sorry, what was V of T? So we found that on part A earlier. So C, given that V of T equals 30,000 times e to the 0.151 t, I'm going to find V prime of t. Okay, so 30,000 stays right there times e to the 0.151 t times the derivative of the exponent, right? ddx of 0.151 t. So what's that going to be? That's going to be 30,000 times, I'll go ahead and do this one first. What's that going to be? That's just going to be 0.151 times e to the 0.151 t. So simplify this. Let me just grab a tiny calculator on my cell phone and just type in 30,000. 30,000 times 0.151 equals 4,530. 4,530 times e to the 0.151 t. So now what are we going to plug in? We're going to plug in 75 in here, and that's going to be the rate of change of the price in 2025. So 4530 times e to the 0.151 times 75 is going to be approximately, let me go to my scientific calculator. What was the number? All right, let's see, 4530 times e to the 0.151, right? 51 times, oh no, I need to put this power in a parenthesis, times what? Was it 75 years since? Okay, 75 times 75 equals that number. I think I entered everything right. All right, so what's that? 375. No, it's big. Okay, let me just go ahead and write this number down on my note. 441. Okay. And then they want it to be in nearest million, right? So this one was 370,390,441. So rounded to the nearest million, this will be, let's say approximately $375 million per year. Let me double check if that's the answer that I typed up. the other day. So number 6C. Yep, $375 million. And look at the unit per year. And there's just, I mean, sometimes these come out so big. I'm like, really? A painting can be this expensive. Okay, so that's how you do part C. I'm gonna need another page. Let me add another page to part D, okay? So 1 second. Add a page. Okay, now what are we doing on part D? How long after 1950 will the value of the painting be? $4 billion. Oh my goodness, $4 billion. Okay, so what we're looking for is the T value this time, right? So in what, no, they're not asking in what year, they're just asking how long after 1950. So we just find T, and that's gonna be the answer. So $4 billion. So D. We do know the equation is V of T equals 30,000 times e to the 0.151 t. We're looking for t, and we want what? V of t, the value of this painting, to be 4 billion. So the question is, how many zeros does a billion have? Is it 9? It's so big. 4 billion is gonna be 9 zeros. So I'll say 4, comma 1, 2, 3, 4, 5, 6, 7, 8, 9. So here we go. We got 4 billion on the left side. And then I'll have 30,000 times e to the 0.151 t. And we're just solving this equation for t. All right, divide both sides by 30,000. 30,000. If I do that, I can cancel out 4 zeros here and 4 zeros here, and I'll have 4 0 0 0, 2 more zeros. So I will have 400,000 divided by 3 on the left side. And then I will have e raised to the 0.151 t. Now take a natural log of both sides. 400,000 divided by 3. And then on the right side, natural log of e raised to the 0.151 t. It's going to simplify to 0.151 t. Therefore, t is going to be natural log of 400,000 divided by 3. And we're going to divide that by what number? 0.15. And that's going to be approximately how many years? Let's go ahead and type that in. 400,000 divided by 3. Clear all. So I'm going to go ahead and type in a natural log of 400,000 divided by 3. And then we're dividing that by 0.15. The answer is 78.67. 78.67. All right. 78.67 years. It's going to take that many years for this painting to turn into a $4 billion worth painting. Oh, wow. Okay, so just, how did I round it? Now, I didn't really type up the rounding rule anywhere for these problems, but I'll try to do that. Okay, so the answer that I typed up was just 78 years, and I'll just be careful on the final exam to ask you to round it. I mean, I'm going to be grading it, so if I see that, that's still really good. Alrighty, and that's it for number 6, C and D. Thank you, Rabat, for emailing me and letting me know that I linked the wrong video. So I fixed 6 AB videos, so it should be the correct one now. My plan is to go over 7 and number 10 today. And those are the only ones that I got an email about. And starting around like noon, I'll work on your exam, and then I will send out something at 6 p.m. this afternoon so that you guys can submit your final